Let's discuss a it's a common data question from thermodynamics. You have a reversible heat engine which receives heat input of 300 and 200 joules from two thermal reservoirs. So you have two thermal reservoirs, one at 1000 Kelvin, the other at 800 Kelvin, and these are giving heat to reservoirs. Okay. Uh, Okay, and this receives at 300 kilojoules and 200 kilojoules. Now it resets heat to a reservoir that is at 300, that is a sink. Okay, 300. Okay, now there are two reservoirs as against the conventional, which you would have seen one reservoir which is a source and one is a sink. So here there are two source and one sink. So now how do you proceed to find out? So first part is that you need to find out Q. Remember that it's a reversible heat engine. Now remember that all this thing begins from Clausius inequality. Clausius inequality for a reversible engine it's this, and for a it's an inequality for a irreversible engine. Okay, it's dq by t. Okay, so basically I am interested in this. In reversible engine what happens? So in reversible engine dq by t is 0, so I'll use the first part because it's a reversible engine, so I'll just use this. So for the first, this can be used for your irreversibility also. In fact I think this has to be greater than for inequality, but that's okay. Our focus is for the reversible engine. Now for two engine, this will term out to be Q1 by T1 minus Q2 by T2, because its heat rejected is equal to 0. So that brings to our QH by TH is QL by TL for two reversible. For three, so any number of sources, any number of saying, the general equation is this. You have to apply this. So now heat input is addition. So Q1 by T1. This is section 1, this is section 2. It's also heat addition, so Q2 by T2. Now heat resetted, so I'll just write minus Q3 by T3 is equal to 0. Now Q1 is already given 300 kilojoules by temperature of the source is 1000. Remember this takes place at very small temperature difference, so 1000 plus Q2 is 200 kilojoules by 800 minus Q3 is something which I need to know. Okay, so from this I can easily calculate Q3, and Q3 comes out to be 165 kilojoules. So remember that just by knowing this reversible Clausius equality for reversible heat engine, you can get the answer. So it's 165 kilojoules. So the answer for part A of this is B, 165. Thank you.